am here to go over our last section in geometry in chapter 2, 2.7. Sorry for the crazy screen. Here we go. So we are going to talk about proving angle pair relationships. So what we have today is we're going to talk a lot about angles, obviously, and when they're paired together, what kind of theorems and postulates we have that describe that. So we actually talked about this again back in chapter 1, where we talked about the different relationships between angles, but we're actually going to be talking about the congruence of those angles. So remember, in geometry, if we say that two angles are supplementary, that means that their measures add up to 180 degrees. We also can say that two supplementary angles are congruent by these theorems that we have. So you're going to want to have your notes, and you're also going to want to have your theorem document that you want to fill in with this. So what we're going to start off with is we're just going to start with several of these theorems. So the first one is pretty straightforward. Theorem 2.3, right angle congruence theorem. And this one's pretty obvious. It is that all right angles are congruent to each other. So remember, congruent is just a way of saying that two angles or lines are the same, and it makes sense that a right angle will be congruent to a right angle will be congruent to another right angle because they're all going to have the measure of 90 degrees. So the first theorem is that all right angles are congruent. Okay, so let me copy that because we're going to be using that word several times today. Okay, and then the next theorem that I wanted to go over is theorem 2.4. It's called congruent supplements theorem. So if you remember the idea of a supplementary angle, that basically means that we have two angles that when you add up the two angles together, they equal 180 degrees. That's the definition of a supplementary angle. And then this particular diagram that I drew is a special kind of supplementary angle called a linear pair, and that'll come into play later. So what we're going to talk about is we've talked about the definition that a supplementary angles add up to 180 degrees, but we're going to talk about congruent supplements. So the idea is if two angles are supplementary to the same angle or two congruent angles, then they are, guess what the word's going to be? They are congruent. Okay, so what does that mean in words here? Okay, so you see this little picture they have here? They have angle 1, 2, and 3, right? If angles 1 and 2 are congruent, and angles 2 and 3 are congruent, I'm sorry, let me go back. If angles 1 and 2 are supplementary to each other, and angles 2 and 3 are supplementary to each other, then we can say that 1 and 3 are congruent. Okay, so in words down here, if the measure of angle 1 plus the measure of angle 2 is 180 degrees, okay, so that just means that they're supplementary, right? 180 degrees supplementary. Yikes. Undo that. Then, and the measure of angle 2 plus the measure of angle 3 equal 180 degrees. Then, let me just go ahead and write it in here. Then the measure of angle 1 equals the measure of angle 3. Okay, so that was a whole bunch of words here, but it kind of makes sense. It's just like our transitive properties that we've been talking about, but now we're talking about supplementary angles on top of it. So basically what they're saying is that angle 1 and angle 2 are supplementary. So they add up to 180 degrees, right? That equals 180 degrees. And then they're saying that angle 2 and angle 3 are also supplementary. So these two add up to 180 degrees. So they share angle 2. Angle 1 and angle 2 share 2, and 2 doesn't change in size. So let's say that angle 2, I'll make it really easy, is 100 degrees. Okay? If it's a supplement to 1, that would mean that 1 is 80 degrees. And it's a supplement to 3, that would mean 3 is 80 degrees. And that means that 1 and 3 are equal to each other. Okay, so it's kind of that idea of 1 is equal to the next. If 1 is equal to 2 and 2 is equal to 3, then 1 is equal to 3. Kind of a similar sharing idea with the transitive property. Okay, so along the same exact lines is theorem 2.5, which is congruent complements theorem. So supplements add up to 180 degrees. Complementary angles add up to 90 degrees. So this is going to be the same rule. Say the theorem for 2.4 applies to supplementary angles. The theorem for 2.5 applies to complementary angles. So if two angles are complementary to the same angle or to congruent angles, then the two angles are, surprise, surprise, congruent. Okay, so they're going to be congruent to each other, the same reason that we had in 2.4, in theorem 2.4. So if the measure of angle 4 plus the measure of angle 5 equals 90 degrees, and the measure of angle 5 plus the measure of angle 6 equals 90 degrees, then the measure, oops, keep forgetting to do that here. Then the measure of angle 4 equals the measure of angle 6. Okay, so that's for the same reasons that we just stated above, except instead of dealing with a total of 180 degrees, we're dealing with a total of 90 degrees. So 4 and 5 are complementary. They add up to 90 degrees altogether. 5 and 6 add up to 90 degrees altogether because they're complementary. Since they both share 5, whatever 5 is, the 4 makes the other part up. So if 5 is, let's make it easy, 60 degrees, right? That's 5. That means that angle 4 is 30 degrees and angle 6 is 30 degrees. It's kind of messy for your notebook there, but you'll want to add those 3 theorems into your list of theorems that we're able to build on. And we actually have one more postulate and theorem to go over today. So let me switch over to that. Pull it off of our document here. Okay, so we're going to talk about postulate 12 and theorem 2.6. So these are building even further on the idea of supplementary and complementary angles and the definitions of those. So if you remember when we talked back in chapter 1 about supplementary angles, there's a special kind of a supplementary angle, and it's called a linear pair. So a linear pair looks like this diagram right here, right? It is 2 supplementary angles. They add up to 180 degrees, and they're next to each other to form this line. Okay, so if 2 angles form a linear pair, so these form a linear pair, then we can say that they are supplementary. Is that all spelled right? Okay, and that means if they're supplementary that the measure of angle 1 plus the measure of angle 2 is 180 degrees. So that's just kind of stating our definition of supplementary angles in terms of linear pair. The other kind of special case that we talked about back in chapter 1 when we were talking about these angles is something called a vertical angle. So vertical angles are not the ones that are complements or supplements, so the ones that match up. These are the ones that are opposite. So in this diagram here, switch over to my brush here. In this diagram here, 1 and 3 are supplements to each other, and 2 and 4 are excuse me, not supplements. 1 and 3 are vertical angles, and 2 and 4 are vertical angles to each other. 2 and 3 would be supplementary angles, and they would also be a linear pair. We have lots of linear pairs and supplementary angles in here, but the vertical angles are the ones that are opposite. Okay, so we have another theorem that deals with these vertical angles, and this one's a super useful one. So vertical angles are congruent. Okay, so what that practically means is that angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. So this really helps us out when we're trying to figure out different angles within our diagram. We can use the fact that these are congruent to help us figure those out. Okay, so that's a bunch of the theorems and postulate that we're going to need to do. So make sure you add all 4 of those theorems into your notebook so you have those. And then the postulate should be listed on the back for you. All right, so now we're going to switch to a couple examples of what we're going to do. I actually have the first example is a proof, and I am going to do that in class. None of your homework actually has you proving it, so I will do that in class first thing on Monday. So what we're going to do is actually use these different theorems and this postulate to figure out some of these different angles. So let me pull that up. Okay, so we have 3 different examples that we're going to go over on the call, and that should give you enough information along with what we just learned about these theorems and the postulate to get through your homework. And like I said, we'll go over the proof on Monday so we can have lots of fun doing that. Okay, so example number 3, we're going to use linear pairs and vertical angles. Okay, so in the diagram, angle 3 is a right angle, and the measure of angle 5 is 57 degrees. So what I like to do when I'm solving these problems is I want to actually use, let's actually zoom in a little here. Nope, I can't see. Not that way. Not quite that far. All right, well, I can't zoom in anymore. So what I actually want to do is draw, let's see if we can get this a little closer here. Draw right on my diagram. Having technical difficulties. Okay, so I want to draw right on my diagram because I think that actually helps you really visualize what you have. So angle 3 is a right angle, so we can indicate that with a right angle, right? And angle 5 is 57 degrees. Okay, so what can we start? We have to find the measures of everything else that's going on in the diagram. So there are actually multiple different ways that we can do this. We know several different properties and theorems and definitions that can help us figure this out. Okay, so the first one that I want to use is the vertical angles, because that's a super easy one. I don't even have to deal with 90, 100 degrees or 180 degrees. Vertical angles are these opposite angles, right, that face each other. And so 2 and 5 are vertical angles because they're formed by 2 lines. So I don't even have to do any work. And because it's a vertical angle, I can tell you that angle 2 is also 57 degrees because they're vertical angles to each other. Okay, so that one was my most straightforward one. So that's the one that I'm going to do first. Okay, so now we're going to talk about using linear pairs to figure out the rest. Well, a linear pair is when we have 2 angles that are next to each other that add up to 180 degrees. So right here, angle 1 and angle 5 form a linear pair. So I know that the measure of angle 1 plus the measure of angle 5 equals 180 degrees. Okay, so measure of angle 5, I've got that. It's 57. Measure of angle 1 equals 180 degrees. And if I subtract 57 from both sides, I get that the measure of angle 1 is 123 degrees. Okay, so that's measure of angle 1 is 123 degrees. All right, so now I have one more angle to determine, which is angle 4. I haven't quite figured out what angle 4 is yet. And this is a little misleading, so I'm going to actually erase that part because really angle 1 is just right there. Okay, so angle 4, we know angle 3 is 90 degrees. There's several different ways that we can kind of figure this out. We could say that angle 3, 4, and 5 add up to make 180 degrees. We could also say that angle 1, which we just found, right? Measure of angle 1 is a linear pair with 3 and 4 together. So measure of angle 1 equals the measure of angle 3 plus the measure of angle 4. Now there's multiple ways to do this, so if you've decided to do it a different way, that's all right. So what we would say is 123 degrees equals 90 degrees plus measure of angle 4. And then I need to subtract 90 degrees from both sides. And I'm going to get 33 degrees is the measure of angle 4. So that's this angle right here. So there's multiple ways that you can do that. So if you've ended up figuring out another way, that's all right too. Okay. All right. So we have two more examples. We'll do them kind of quickly here. Find measure of angle 1 and measure of angle 2. So right off the bat, I might think, oh, this is super easy because I'm just going to use my vertical angles and everything's just going to work out. But if you look, these aren't vertical angles because this crazy line here is bent. So that's not going to work. But it looks like angle 1 and angle 2 are linear pairs to each other, right? They have the same line. So those are definitely a linear pair. So I can say that the measure of angle 1 plus 21 degrees equals 180 degrees. And that would lead me to that the measure of angle 1 is 159. Okay. And then it looks like over here that we have 32 in the measure of angle 2. Also are a linear pair. And so if I do the math on that, I'm going to get that the measure of angle 2 is 148 degrees. Okay, and last one, because we have to throw some algebra in there, right? We have find the measure of each angle. So they don't even make it tricky for you here. They're just using the linear pair postulate, which just tells me if I have a linear pair, then that equals 180 degrees. So that means 3x minus 17 plus 6x plus 8. So these are my two angles, right? This angle plus this angle equal 180 degrees. So now I have to remember my algebra. So 3x plus 6x is 9x, and negative 17 plus positive 8 is negative 9, equals 180 degrees. 9x equals 189. Divide both sides by 9, and I get x equals 21. Okay, so they don't just ask me to find what the measure is, they actually ask me to solve it, so you would need to plug x in for each of those to find the angles. All right, guys, that is everything for 2.7. Thank you for watching. We will again go over the proof in class on Monday, but you should be able to do all of the homework because we don't have any proofs in there. So hope you have a good day. Talk to you later. Bye.